Very good morning, dear students. Today we are going to discuss about properties of fluid. Okay. So before we discuss about properties of fluid, uh, let us know what is a fluid. Okay. So what is a fluid? Fluid is a substance which continuously deforms under the action of shear stress. Fluid is a substance which continuously deforms under the action of shear stress. Okay, so fluid is a substance which continuously deforms under the action of shear stress. Fluid has some characteristics. Fluid has some characteristics. Okay, fluid has the main characteristics of flowing from higher level to lower level. Fluid has no fixed shape and size, which fluid has no fixed shape and size. It takes the shape of the container that it is kept. Okay, so fluid takes the shape of that container, okay, in which it is kept. Fluid may be liquid, may be gas. Okay, so what is fluid? The fluid is a substance which continuously deforms under the action of shear stress. How a fluid is identified? How a fluid can identified? Okay, so what are the properties? Okay, what are the behaviors fluid can show? So properties of fluid are the behavior of fluid that one fluid can show. Okay, so first behavior is the density or mass density, or we can say specific mass. Okay, so density or mass density or specific mass. So density of a fluid is defined as the ratio of mass of fluid to its volume. Okay, density of a fluid is defined as the ratio of mass of fluid to its volume. Okay, so we can say mass per unit volume. Mass per unit volume. Okay, it is denoted by the symbol rho. It is denoted by the symbol rho. Okay, so mathematically rho is the mass of the fluid by volume of the fluid. Rho is the m by v. Rho is equal to m by v, mass of the fluid by volume of the fluid. Okay, so its unit is kg per meter cube. Its unit is kg per meter cube, because unit of mass is kg and unit of volume is meter cube. So total तुम्हारा density, unit of density is the kg per meter cube. Okay, so density of water is 1000 kg per meter cube. Okay, it is very important, it is very necessary to remember. Okay, so because it is very necessary for solving the problems in fluid mechanics. Okay, so density of water is 1000 kg per meter cube. Okay, so our next slide is the next property, specific weight or weight density. Specific weight of a fluid is the ratio of weight of the fluid to its volume. Weight of the fluid to its volume. Okay, so it is denoted by the symbol small w. It is denoted by the symbol small w. Okay, so mathematically specific weight or weight density is the weight of fluid by volume of fluid. Okay, w by v, weight of fluid by volume of fluid. Okay, so its unit is a Newton per meter cube in SI system. It is in its unit is Newton per meter cube. Okay, because the unit of weight is Newton, and the unit of volume is the meter cube. So unit is Newton per meter cube. We can write in the place of weight is mg, because weight w is as we know, weight w is mg. Okay, so we can write here in place of weight is mass into acceleration due to gravity, m into g. Okay, so I already discussed about mass by volume is the density. Mass by volume is the density. So mass by volume, we can write mass by volume is the rho, and the acceleration due to gravity is the g. Okay, so we can write here specific weight is the rho into g. There is another expression for specific weight, that is w equal to rho g. Specific weight is the rho into g. Okay, so there is another formula for specific weight. Okay, so rho into g. So value of specific weight for water is 9810 Newton per meter cube. Because so value of rho for water is the 1000, g is the 9.81, so 9810 1000 into 9.81 equal to 9810 Newton per meter cube. Okay, so it is a specific it is all about specific weight or weight density. Okay, so next is the specific volume. Okay, so specific volume of a fluid is defined as the volume of fluid occupied by a unit mass. Specific volume of a fluid is defined as the volume of a fluid occupied by a unit mass, or we can say it is the reciprocal of mass density. It is the reciprocal of mass density. Okay, so its symbol is 1 by rho, reciprocal of mass density. So its symbol is 1 by rho. Okay, specific volume is the volume of fluid by mass of fluid. Volume of fluid by mass of fluid. Its unit is meter cube per kg. Okay, so unit of volume is the meter cube, and unit of mass is the kg. So unit is the meter cube per kg. Okay, specific volume is the volume of fluid by mass of fluid. Okay, so it is the reciprocal of mass density and is expressed as meter cube per kg, and it is commonly applied to gases. Okay, so our next slide is the next property, that is specific gravity. Okay, so specific gravity is also called as relative density. Okay, why is it called relative density? Relative density because it shows the relationship between density or specific weight of a given fluid and density or specific weight of a standard fluid. So it is known as a relative density. Okay, so relative density or a specific gravity. Okay, so what is specific gravity? Now it is defined as the ratio of the weight density. It is defined as the ratio of weight density or density of given fluid to the weight density or density of standard fluid. Okay, so it is defined as the ratio of the weight density or density of given fluid to the weight density or density of standard fluid. Okay, so for liquid, standard fluid is taken as water. For gases, standard fluid is taken as air. Okay, standard fluid is taken as air. Okay, so mathematically specific gravity is denoted by the symbol S. Mathematically specific gravity the mathematical specific the symbol of specific gravity is the S. Okay, S. Mathematically specific gravity S is the density or a specific weight of a given fluid to the density or specific weight of a standard fluid. Okay, specific gravity is denoted by the symbol S. Specific gravity is denoted by the symbol S. Okay, so what is specific gravity? Now density or specific weight of a given fluid to the density or specific weight of a standard fluid. Okay, so from that formula we can say specific gravity. We can say specific gravity of liquid is density or specific weight of given liquid by density or specific weight of water. Okay, specific gravity of liquid is the density or specific weight of given liquid divided by density or specific weight of water. Or specific gravity of given gas. specific gravity of a given gas is the density or specific weight of given gas by density or specific weight of air. Okay, so air is the standard for gas. Okay, so here water is the standard standard for liquid. Okay, so from that formula, we can express or we can calculate. Okay, we can calculate density or specific weight of given liquid. Density or specific weight of given liquid is the specific gravity of liquid into density of density or specific weight of water. Okay, so density or specific weight of given liquid is equal to specific gravity of liquid into density or specific weight of water. Okay, similarly, density or specific weight of given gases, we can calculate density or specific weight of given gas is equal to specific gravity of gas into density or specific weight of air. Okay, so in next slide, just that formula, written that formula. Okay, so density or specific weight of liquid, just cross multiplication. Okay, density or a specific weight of liquid is the specific gravity of liquid into specific weight of water. Okay, so density or specific weight of gas is equal to specific gravity of gas into density or specific weight of air. Okay, so this is all about your specific gravity. Okay, so what density or mass density is the ratio of mass of fluid to its volume. Okay, density is the m by v. It is denoted by the symbol rho. Okay, then what is specific weight or weight density? It is the ratio of weight of the fluid by volume of the fluid. Okay, so w by v, it is denoted by the symbol small w. Okay, so then a specific volume, it is the reciprocal of mass density. Okay, so volume of the fluid by mass of the fluid. Okay, 1 by rho. Then what is the specific gravity? It is also called relative density. Okay, so specific gravity is the ratio of mass density or a specific weight of a given fluid by mass density or a specific weight of a standard fluid. Okay, or it is a unitless quantity. Okay, specific gravity is a unitless quantity. Okay, so our next property is the viscosity. Okay, viscosity. So viscosity is the main property which is responsible for flowing a fluid. Okay, so a fluid can flow for this property, viscosity. So what is viscosity? Viscosity is the property of liquid which offers resistance to the movement of one layer of fluid over another adjacent layer of fluid. Okay, so viscosity is the property of liquid which offers resistance. Viscosity is a property of liquid which offers resistance to the movement of one layer of fluid over another layer of that fluid. Okay, so that is known as your viscosity. So in the next slide, with the help of this graph, we can explain viscosity. Okay, so viscosity, there are two layers. U. There are two layers u, and there are two layers having velocity u and u plus du. Okay, you can see. So there are two layers having velocity u and u plus du. Okay, so having distance dy, okay, so the two layers are flowing, so the two layers causes relative velocity, shear stress because the relative velocity of these two layers. Okay, so the lower layer causes shear stress on the adjacent upper layer, and the adjacent upper layer causes shear stress on lower layer when the two layers are flowing. Okay, so when the two layers are flowing, the lower layer causes shear stress on the upper layer, and the upper layer causes shear stress on the adjacent lower layer. So the two layer having relative velocity, the two layers causes the shear stress. Okay, causes the shear stress. So in next slide I will discuss when two layers of a fluid at a distance dy apart move one over the other at a different velocity u and u plus du. Okay, so when the two layers flowing, when the two layers flowing, the top layer causes a shear stress on the adjacent lower layer, while the lower layer causes shear stress on the adjacent top layer. Okay, so these are two layers causes a shear stress. The two layer causes a shear stress. Okay, so the velocity together with relative velocity causes a shear stress when the fluid layers are flowing. Okay, so that shear stress that caused shear stress for of of that two layers, okay, is proportional to the rate of change of velocity. Okay, the shear stress caused is proportional to the rate of change of velocity with respect to y. Okay, the shear stress mean the top layer causes shear stress on the adjacent lower layer, and the lower layer causes a shear stress on the adjacent top layer, that shear stress in between the two layers. Okay, so the shear stress caused is proportional to the rate of change of velocity with respect to y. So we can write the shear stress is the tau is directly proportional to du by dy. Okay, tau is directly proportional to du by dy. Okay, so we can write tau is equal to mu du by dy. Tau is directly proportional to du by dy, or you can write tau is equal to mu into du by dy. Okay, du by dy. So what is mu? Mu is the constant of proportionality, and it is known as viscosity or dynamic viscosity. Mu is the constant of proportionality, or we can say it is a dynamic viscosity or simply viscosity. Okay, so tau is equal to mu du by dy. Okay, so what is mu? Mu is the constant of proportionality, or you can say dynamic viscosity or simply viscosity. So what is mu? Dynamic viscosity is equal to tau by du by dy. Okay, dynamic viscosity is the mu is dynamic viscosity is equal to tau by du by dy. Okay, so in next slide, dynamic viscosity mu is equal to tau by du by dy, where dynamic viscosity mu is the constant of proportionality, and it is known as a coefficient of dynamic viscosity or viscosity. Okay, so the du by dy represents the rate of shear stress or velocity gradient. Okay, the rate. So du by dy represents the rate of shear stress velocity gradient. Okay, so we can define viscosity. Viscosity is also defined as the shear stress required to produce unit rate of shear strain. So here another law is there, Newton laws of viscosity. Okay, Newton's laws of viscosity. Okay, Newton laws of viscosity states that the shear stress produces between two layers is directly proportional to the directly proportional to the velocity gradient. Newton's laws of viscosity states that shear stress is directly proportional to the velocity gradient. Okay, tau is directly proportional to du by dy. It is known as Newton's laws of viscosity. The fluid which obeys this law, this Newton's laws of viscosity, is known as Newtonian fluid, and the fluid which do not obey the Newton laws of viscosity is a non-Newtonian fluid. Okay, so Newton laws of viscosity states that the shear stress between two fluid layers is directly proportional to the velocity gradient. Tau is directly proportional to du by dy. Okay, for viscosity, the units are in the units of viscosity in SI system is the Newton second per meter square, in CGS dyne second per centimeter square, in MKS kg for second per meter square. Okay, so in next class we will discuss what are the what are the details expression, what are the details derivation of this unit of viscosity. Okay, and already discussed about kinematic viscosity. Okay, so thank you for today's class. Okay, thank you so much.